Hey guys, how are you doing? I hope you're fine. We are in chapter 7 and we're looking at section 7.5, which is actually not going to be that bad. You're going to find that you've done a lot of this before. And this section is all about adding and subtracting polynomials. So here's what we've got. We've got two examples, no vocabulary. Please pay attention. I'm going to show you two methods for solving the problem, and I will let you know about my bias of one method that I like best. So let's get started. So here we have we're going to add polynomials, and the other example is about subtracting polynomials. So that's the only two things we'll talk about today. So here's the deal. When we're adding polynomials, what we're doing is we're looking at this and we're looking at this and we're going to join them together. And really what it comes down to is joining like terms. When there's an addition sign here, technically we can literally just say 2x squared plus 5x minus 7 plus 3 minus 4x squared plus 6x. You may have done something similar to this in 7th grade. So this is not that big a deal or not that deep. You're going to simply take this term and this term because they are like terms. By the way, remember that x and x squared, though they are related terms, they both deal with x, they are not the same because they do not have the same degree. So you can unite terms that have exactly the same degree and the same variable, and so we can take 2x squared minus 4x squared, together we get a negative 2x squared. Then I like to kind of cross them out, helps me out. Then I can take 5x and 6x. Are there any other x terms? Nope. So I'm going to bring those together. A positive 5 and a positive 6 gives me a positive 11x. Finally, I'm going to take these, which are my constants. I think that kind of obscured, and I'm going to take those off very quickly, taking my time. I'm going to take the two constants, which are negative 7 and positive 3. When I add a negative 7 and positive 3, I get a minus 4. And guess what, guys? We've added a pair of polynomials. Yay! All right, so this is great. What your textbook is going to show you, and this is my preferred method, by the way. Just take the numbers, join like terms together. What your textbook will show you, I hope you copy this down if you like it, because I'm about to delete it. The textbook will show you taking the terms and lining them up. They're going to show you the vertical method. So what we just did was the horizontal method, but they'll show you the vertical method, and that is taking each number or each of the terms and lining them up. So I would take this negative 4x squared, put it underneath the x squared, put the positive 6x here, put it underneath the 5x, and put the positive 3 here, because it is a positive 3, though it's followed by a subtraction sign, and I'm going to add them. So notice I organized it in standard form or descending order. Notice that this is already organized in descending order or standard form. I've lined them up, and now I will add them. Negative 4, positive 11x, and then we end up with a negative 2x squared. It's the same thing. My only reason for not preferring this method and looking forward to just doing it the horizontal method is generally when you get these problems on an assessment or a test when you get to high school, they're just going to be like that. So why go through the process of reorganizing if you can see how to organize it as you add it? That's the only reason. There's nothing wrong with the vertical method and lining it up and putting them both in standard form, but it's just not what I like to do. So if you guys like to do that, feel free to do it. We can talk about it with this next example, and then we're probably going to stick to the horizontal method. All right, so here I've got a number of terms. Again, since I'm adding it, there's really nothing that happens here that changes. So I'm going to simply be adding 3y plus y to the third power minus 5. By the way, I would not even rewrite this if I were doing the horizontal method, because this plus sign doesn't change anything here. And I'm emphasizing that because when we do subtraction, it will. So we need to keep that in mind. So 3y plus y to the third power minus 5, blah, 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 minus 4y plus 2y to the third power plus 8. So again, I'm going to underline like terms. So I got, notice that the highest degree is a third degree. So I'm underlining all my third degrees. I might go back and double underline my second degree polynomials, get my single degree polynomial, or terms I should say, and then sometimes I just circle my constants. So this helps me organize without having to rewrite and reorganize, and sometimes I don't do that at all. All right. So y to the third power plus 4y to the, no, y to the third power plus 2y to the third power is going to give me 3y to the third power. And I see I've dealt with those. The next thing I have is y to the second power. And I only see one term, so I'm going to put down plus 4y to the second power. The next thing I'm going to do is deal with my single power here, or my linear power as we will one day call it. And a negative 4y plus a positive 3y is a negative y. And then finally, I got my constants. Negative 5 plus a positive 8 gives me a positive 3. And that's it. Again, I could have lined these up, organized them in a different way. But that's really all there is. You've seen this before. I know you have. All right, so let's look at subtracting polynomials. So to subtract polynomials, here's what we need to do. This requires a little bit of rewriting for me. I like to do it. You can do it in your head, but I think it's easier to do it this way. So the first term is going to, the first polynomial will stay exactly the same. But when you're subtracting, what you're ultimately doing is changing the sign of each term in the polynomial. So I like to literally rewrite that 3 minus 2x plus 2x squared minus 4x negative, and a negative gives me a positive 5. That's why it's like we're distributing that negative through. Negative and a positive gives me a negative 3x squared. After that, this is exactly the same problem as we had before. We're just joining like terms. We're going to honor the sign in front of the term and use that to simplify our situation. So again, look for the highest degree. I like to look for the highest degree because I'm putting it in standard form like automatically. So 2x squared and a minus 3x squared is going to yield a negative x squared. When I'm done with those x squared terms, I'm going to go to my x terms, and I get a negative 2x and a negative 4x is going to give me a negative 6x. And finally, 3 and a positive 5 is going to give me a positive 8. And I got rid of those, I dealt with those, and I think I'm done. Here's another thing. Sometimes students get into the habit of wanting to solve things. Remember, this is just an expression that you're simplifying. There's no answer that we're looking for except to make this thing smaller or more simple or more compact. Let's look at this next one. So again, I'm going to distribute through. So as I look at 7p plus 4p to the third, plus 4p to the third power, sorry babies, plus 4p to the third power minus 8, I'm looking at this as minus 3p squared minus 2, distributing that negative through, plus 9p. And again, joining like terms together, it's like a party in a textbook. We only have 4p to the third power. It's alone by itself. That's the only third power term that I have, but I do have a second degree term, which is this guy and only one. So it becomes a minus 3p squared. That's gone. Now I'm going to join these guys together, 7p and a 9p, come together to give me, what's that? What did you, yeah, 16p, good. And then we have a negative 8 and a negative 2, which is going to come together to give me a negative 10. Voila, I'm done. As simple as possible. All right? I hope this made sense. Please let me know if you have any questions, and we'll talk soon. Bye-bye.